Hello, I'm Dr. Harper. This video is an inventory homework Excel tutorial on ABC inventory classification analysis. So let's bring up the question. So in this question, an ABC inventory classification of a 20-item inventory resulted in the classification 4511 of inventory items and a total annual dollar usage given for classes A, B, C, respectively. Assume the unit ordering cost is $1.35 per order. Unit carrying cost is $4 per dollar carried over a year. Complete each statement. So let's bring this up here and let's bring in Excel and solve these questions and just do an inventory analysis with this classification and an optimal classification. So let's bring up Excel. Okay, and let's come over here. Let's broaden this a little bit. Let's get the information in here. Here we go. Let's make this a little bigger. Okay. So now then, let's have the this is say ABC classification, and here is going to be, let's say, our class, which is A, B, and C. Okay, and then the usage, and that usage is given right here, 349,852. That's this one. The second one for class B down here is 65156, 65156. For class C is 25785, 25785. Okay, and then the actual classification, the numbers in each class is 4, 5, 11. 4, 5, and 11. There we go. Okay. Now the okay. Now up here, the unit cost. Let's put this up here. C sub O is 135. Okay, and then C sub C is 4, but it's $4 per dollar per year. So therefore, the EPP will equal, which we've seen in class, the ordering cost divided by the carrying cost, which is 33 and 3/4. Okay, and then let's see here. Okay, so let's look at these statements. So there we have it. We have the setup. Okay. And then usually right here, we're going to have a frequency. Then we're going to have NF, the number and the frequency, and then the average inventory. Okay. And then we can have the EPP over here. So we're going to be building this here in just a second once we have a policy here for the frequency. And let me just box that in. Until we have a frequency, which is our policy, we will not be doing anything until we get this policy. Okay, so let's go back to the problem. For the inventory policy 221411, which are the annual order frequencies for classes A, B, C respectively, the total annual order frequency is 279. Okay, for the EPP for an inventory policy of 221411, which are the annual order frequencies for classes A, B, C respectively, is approximately 41 for the entire inventory. Okay. And then the optimal inventory policy, let me underline that, that minimize the total inventory is, and it's given here, 36, 14, and 6, which are the annual order frequencies. Okay, is that optimal? And we'll complete this statement. Now for the inventory policy 221411, go back to this, which are the annual order frequencies, the minimum cost inventory policy, and let me again underline the minimum cost under inventory policy, will decrease the total cost, inventory cost, for this inventory policy up here by approximately that much. So we're looking what the difference is, what the difference between this inventory policy and the optimal inventory policy. Okay, so let's bring back and let's just simply do, first let's do the 221411, right here, 22 1411. So there's our first policy. So let's go ahead and do an analysis with this. Okay, NF is N times F, and there we go, and bring this down. The average inventory equals our usage divided by our frequency, that's our order, lot size, then we divide that by 2 to get the average inventory, and then we bring that down. Now the EPP, and I'm going to say EPPO, which is just the observed. This is not necessary. It's not going to be optimal because unless this is optimal, we'll see in a minute. If the EPP is 33.75, then it's optimal. Let's see. That's going to equal the average inventory divided by our frequency. Well, it's not. It's 90. Class B is 33. Well, that's close, but then Class C is 9. Okay, so A has a much higher EPP than it should. B is close, but C is too low, so it's not optimal. Okay, so there's the. Then let's see what the questions are. The total annual order frequency and the approximate EPP for the entire inventory. Okay, well, we have to do a little bit more here. Let's sum each of these. So we'll sum the frequencies. We'll sum the inventories, and then we'll bring down the EPP for the entire inventory. It's approximately 41, and we see here it's approximately 41 right here. And the total annual frequency is 279, and it's 279. So there they are. Okay. But now that we have this, we can bring down the unit costs, which is going to be 235 and 4, and we can get the total cost. Which equal the sum times the unit cost. Bring this over, and then we get the total, the grand total, which is equal to these two, this plus this, and we'll get that's pretty much the going to be the cost of this policy. Okay. Now, that's the first two questions. Now, the questions 3 and 4 says the optimal inventory policy. Okay. So now let's calculate the optimal inventory policy. Okay. Well, if you recall, let's say I don't have it here. I didn't have it in the notes, but let's see here. So the optimal right here, the F will be the square root of the usage. I'm going to say the usage, right? Let's let me bring in. See, let me bring in the. Well, I'll go ahead and left justify this. Square root of the usage, okay, divided by, open parenthesis, 2 times the N for that class, the usage for the class divided by N for the class, times EPP. Okay? And so that's going to be the equation for the optimal frequency. So we have it right there. And so let's now let's come down and do it down here for A, B, and C. So let's take these again, copy these, and bring them down here. There they are. A, B, C, copy these, and bring these down here. Okay. And then we're going to have, actually, let's let this equal A, bring this down like this, and then bring this over, because those are going to be the same as up there. Now let's get F. Okay, this is going to equal the square root of simply the usage divided by, open parenthesis, 2 times the frequency. I mean the number. It's going to be that right there times EPP, which is given right there, and I'll freeze that. Okay, and then I'll copy that down. And notice if I reduce these, all the significant figures are there, but I'm just reducing them down. And right there we can see it's 36.14.6, 36.14.6, so that is the optimal inventory policy. But then the second question is, what's the cost savings? Okay, well, let's continue on, and let's go ahead and box this in, because that's going to be our optimal. And so then the NF equals N times F, average inventory equals a usage divided by F divided by 2. Okay, and then the EPP will equal the average inventory divided by the frequency, and that should be 33.75. And we'll just copy those down. Boom, 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 and there we go. See, there's our, and this is no longer observed. This is optimal because it's the 33.75. It's optimal. Why is this the same? Because this was derived to make the EPPs the same, so it's economically balanced. Okay, so now let's sum this. Sum the frequencies, copy this over, and sum the average inventory, the unit costs here, and the total cost. Okay, the unit cost is 135, 4. Okay, and then the total cost simply is the sum times unit cost. Copy it over. You know, we have all these decimal places. Let's just reduce them, because let's just go whole numbers. There we go. Just to be cleaner. Okay. And then the sum, the grand total. Equals sum of these two. Okay, and then I'll say the difference. Equals, well, this is going to be more, minus this, and the difference is going to be 8330. Okay, and we can reduce these down too. These don't have to be so. Go down to the, whoops, oh, that's okay. Go down to the units. I mean to the units place or whole numbers. There we go. So 8330, and sure enough, it's 8330. Okay, and so this just shows by changing this policy here to increase the 22 to 36, the 14 stays the same. Decreasing the 11 to 6, then it takes these EPPs then, and then it's going to align them better with optimal. And when you do that, you're balancing. Let me bring this over so you can see it. Let me say that again. The EPPs are not balanced at all. So if you take the frequency here of the A class and change it, increase it, and the B pretty much stays the same, but the C decrease it such that these EPPs are in line with the optimal EPP, what happens is you begin to decrease the costs, decrease the cost significantly. And here it would decrease the cost by $8,330 a year. And so that can build. That's every year. or whatever your planning horizon is, then you have a savings. So that's all I have for this analysis. There's more analyses, but this is good for here for now. This is Excel tutorial for ABC inventory classification. I hope this helps. Between now and the next time I see you, please be safe and take care.